Okay, so in our last lesson we talked about congruent figures, congruent triangles. In this lesson we're going to talk about some congruence shortcuts. So before, we needed to prove that all three angles and all three sides of two triangles needed to be congruent in order for the triangles to be congruent. So today we're going to learn about a few different shortcuts to prove triangle congruence. The first shortcut is called the side-side-side postulate. And what it states is that if three sides of one triangle are congruent to the three sides of another triangle, the two triangles are congruent. So in this triangle, or in these two triangles, AB is congruent to DE, BC is congruent to EF, and then AC is congruent to DF. So if we can prove that all three sides of two triangles are congruent, then we can say that the triangles are congruent. So in example 1, we're going to use a proof to talk about this Sss theorem. So in this proof, we're given that BC is congruent to BF and CD is congruent to FD. So in the first two statements, I can say that BC is congruent to BF because it's given, and CD is congruent to FD because it's given. So we need to prove that one more pair of sides is congruent. And the side I'm going to focus on is BD, because we have two triangles here, a triangle on the top, a triangle on the bottom. They share this side BD. So BD is congruent to itself because of that reflexive property of congruence we talked about in our last couple chapters. So we can say that triangle BCD is congruent to triangle BFD by that side-side-side postulate. So it's being able to prove that three sides of one triangle are congruent to three sides of another. The other postulate we talk about today, the other shortcut, is the side-angle-side postulate. And this postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, the two triangles are congruent. So if I'm looking at two triangles that would be congruent by this SAS, I'm going to look at DEF and SRT. Now, not in that order, but what I could say is that triangle DEF in this diagram is congruent to triangle, and the way I name it is important. If I name it DEF, I have to name the other triangle TRS, because T corresponds to D. T corresponds to D, R corresponds to E, S corresponds to F. So those are congruent by SAS. Those triangles are congruent by SAS. So the angle in the middle of two congruent sides. So an example of using this SAS postulate is, I'd ask you a question like, what other information would you need to know to prove that these two triangles are congruent by SAS? So with these two triangles, we're given that, this angle up here and this angle down here are congruent. One thing we could assume is we can assume that LB is congruent to LB by that reflexive property. Okay, so we can assume that this side is congruent to itself. So the other thing we would need to prove, SAS, is that BN and LE would be congruent. So we need to show, or we need to be given, that LE, segment LE, is congruent to segment BN. Because then I have this, I'm going to use a highlighter, I have this side, angle, side for one triangle, side, angle, side for the other triangle. So side, angle, side pretty much states if two sides and the angle in between them of two triangles are congruent, the triangles are then congruent. So that's another shortcut. And then one more example before you get a little bit of practice on this is identifying congruent triangles. So this is asking, would you use SSS or SAS to prove the triangle is congruent? And this is a little tricky because you're given all three sides and you're given an angle. So at first you think it could be either one, but I'm going to say that you would use SSS, all right? SSS. And the reason I would use SSS is because I have three corresponding sides that are congruent. Now the reason I can't use SAS is because this included angle is not included between two congruent sides. In the left-handed triangle, in the triangle on the left-hand side, it's sandwiched between the side with 2 markings and the side with 3 markings. In the triangle on the right, it's sandwiched between the sides with 1 marking and 2 markings. So those aren't corresponding. So I would say SSS because corresponding sides, I'll try to write that better. Corresponding sides are congruent. So corresponding sides are congruent. So that's why I can say these triangles are congruent by SSS and not SAS. So you'll get some practice differentiating between the two.